Cleviscope can calibrate standard probes as well as calibrating BNC cables. We assume that the cable is 50 ohm terminated. This is automatically detected by the FRA software. The advantage of BNC cables is that their bandwidth is much higher. We can do measurements on components up to 65 MHz. The BNC cables are connected in a T. The SIGGEN feeds into both channel A and channel B. Here we have a homemade test jig in which a 0 ohm resistor connects A, B and the SIGGEN together. Once we've got it all connected together, let's start the Cleviscope application. Right, as for the standard probe calibration, with the BNC probe calibration we need to set the frequency range. We've set it to 1 kHz to 65 MHz, the upper frequency limit for the FRA. We set a SIGGEN amplitude of 2 volts, and again we're going for 20 steps per decade. We're going to measure gain phase without any probe correction just to see what we've got. We see a gain variation of about plus or minus 0.1 dB, which again is not too bad, and phase is varying by up to 1 degree. This is because the jig has added some parasitic effects to the transfer function. Now we will compensate for it. We will go to the calibrate probes and do another sweep. Right, next we can check how the sweep has affected things. We change back to gain phase and do another start sweep. Now we should have the corrected version of the gain phase response for this jig and these cables. As you can see, the gain is now very flat and the phase response is very close to 0. Once we've done this compensation, values are saved automatically in the Cleviscope setup file. And if you save the response as an APC file, the values are saved in there also. The calibrate probes process not only makes sure that channel B has the same gain and phase response as channel A, but it also makes sure that both probes have a flat amplitude response. So we actually multiply the gain by a certain amount at each frequency to make sure that we see a flat amplitude response. Let's check this out. Here we have the two probes again connected together in the BNC jig with a frequency range of 1 kHz to 65 MHz. We leave probe correction off. We start the sweep. We see an RMS level, we've set the RMS amplitude, of about minus 12.5 dB. As you can see, as we get up in frequency, it starts falling off. This is the frequency characteristic of the signal generator. Now we turn on probe correction and we redo the sweep. Now you can see the sweep is flat all the way from 1 kHz to 65 kHz. In this way you know that the RMS levels that you are measuring are correct and not varied by the output signal generator level or by probe impedance. Again, we commend the BNC calibration procedure to you for your use in measuring components and systems.